Hello everyone. So in this video we'll be going over the OpenZeppelin Ethernaut Gatekeeper 2 challenge. And so this challenge is the next challenge after Gatekeeper 1. So it's a similar problem where we have 3 modifiers that we need to get through to be able to make ourselves the entrant here. So I'm going to go ahead and get a new instance. And we'll just look at our JavaScript console. So just in View Developer JavaScript console. Okay, so there we have our address. So I'm just going to copy that address and let's head over to our Remix IDE. So in the Remix IDE, I've already written a little bit of code just to speed things up. So I've defined our Solidity version 0.8.0. This version number will become important just a little bit later on. And we've also got our defined our interface, Gatekeeper 2, and so we want to run this enter function. Okay, and so we want to create a new contract. Let's call this attack. Okay, and so what do we put in this contract? Well, let's look back at our vulnerable code. So if we look at our gate 1, we require that the message.sender does not equal to tx.origin, which can easily be achieved by running this contract through another external contract, which is what we're doing. So we can pass that one very easily. So for gate 2, our requirement is that we've got an assembly here. So in assembly, we're taking x to equal the external code size of caller, which is basically taking the size of the code in the caller, essentially. So and so that is required to be 0. So this might seem a little bit unintuitive at first. So we're requiring that this contract, this enter function, is called from an external contract, but we're also requiring that that external contract has no code in it, which seems a little bit impossible. But this can actually be achieved by using a constructor, because a constructor actually doesn't count towards this code size. And so if we put all of our code in our constructor, this exe code size of caller will actually equal 0. So we can easily pass this modifier by using a constructor to run our enter function. So that gate should be easy to pass as well. And for our gate 3, this is the tricky part. So we're requiring that the encoded and hashed value of our public address that we're calling this contract from, so this is the external contract's address, XORed, so exclusive OR with the gate key, that has to equal uint64 0 minus 1. So uint64 0 minus 1, if you have a look back at our Solidity version, this version is 0.6.0, and underflow and overflow protection is only supported above 0.8.0. So we're going to basically have an underflow here, and so this will be the largest uint64 value that is going to be here. And if you think about the largest uint64 value, that is all just 1. If you think about the bits, so 64 ones. So we all require all the digits on that on the bits to be 1 after this XOR function. Okay, so to think about yeah, so let's go back to our remix IDE, and so by calling it from a contract, we're already passing gate 1. To pass gate 2, we need to call our enter function through a constructor. So let's make a new constructor. Yeah, and there we go. So we've got a new constructor, and then let's create our Gatekeeper 2. So Gatekeeper 2 target, and that's going to be our address that we copied earlier. Which is just right over here, so this address. Okay, so we've got our target, and now what we would like to do is we want to call that enter function. So let's call that enter function target.enter, and we will need a key. So let's make our key just above our enter call. So let's do key equals to, let's create, so key must be bytes 8. And what we want to do here is to generate a key, right? So we've got key equals to something. And to think about what our key needs to be, let's first look at this code here. So we've got uint64 uint bytes 8 of the hash of message.sender. So let's call this value x. So we're going to call that value x. I'm going to write that just down the bottom here. And then our key here, so we're XORing that with our key. So XORed with key, and that has to equal this value here, which is all ones. So let's just call that y. Okay, so we've got this now, and so now if we just do an XOR on both sides of the equation, so we're going to do x, XORed x, XORed key, and that's going to equal x, XORed with y. So I actually, what I did was I just put that x XORed on both sides of the equation, as you can see here. And of course, x XORed with itself, that just disappears, and so we're just left with key equals to x XORed with y. Right, so this is what we want to do. So x, if you remember, was this value here. So let me just copy this. This is our x. But this will be not message.sender, but this will be address this. And we're doing XOR with y, which we said was this value here. Okay. So that's what key is equal to, and we're just going to pass that key into our enter function. And also one thing to note is that we're using an underflow here, but if you look back here where we've defined 0.8.0, and so underflow will not work in this situation. So what we can use is we can just use the unchecked. We can just say unchecked, and then we'll compute our key here. And so what this does is it just allows underflows and overflows to happen inside of this unchecked section here. So this, and then I've forgot a semicolon here. And so this should compile if I just delete all of these at the bottom. We're getting an error. Yes, so we need to convert this to a bytes 8. just so we can pass it into that enter function here. Okay, so this compiles properly, and so now if we deploy this contract, so I'm going to deploy that. I need to change this to attack and deploy. And so as soon as this contract deploys, we should be running the constructor, and this constructor is calling our enter with the correct key, hopefully, and so that should straight away just get us through all of the modifiers and register ourselves as the entrant. So let's just double check that that has occurred. So we're going to do await contract dot entrant, and you can see that this value is not 0 anymore, and I can prove to you that this is my address by just doing player, and you see these the player and the contract entrant address are matching. So we've successfully completed the challenge, and so now I'm just going to go ahead and submit that instance. Okay, and so if we go back to our console and just wait a moment, we should see that we have completed the level. Yep, and there we go. So we have successfully completed this level.